and I've chosen the challenge, Will It Rain on My Parade? So the objective with this was to develop a weather prediction application that offers weather forecasts not just for days in advance, but months or even weeks, within a degree of certainty. This is useful for people who want to plan outdoor events or companies who want to plan and set hard deadlines for outdoor projects. So I'll break it up into four main chunks of how I did it, which is starting off with data collection and then moving on to averaging. I average out the data, and then finally collecting the anomalies, which is weather trends, and then combining them together to get a more reliable estimate. Did you know that NASA has been collecting weather data for over 30 years? I didn't. Apparently they are. So, as you see right there, that is MERA 2, which is part of their disk collection, which is basically weather data they've been collecting for over 30 years, every single day, all over the Earth, using satellites and other temperature, and dust, and rain, and snow sensors. If you want to see weather tendencies or how they've, or with the weather in the past for any location, you can go on there and you can see within 1/8 of a degree of accuracy, which is very accurate and can be used for my project or any other project with weather to basically estimate or make averages and guesses. It's the same sort of technology that all other weather apps use, essentially. Not just from NASA, but same kind of technology. So data averaging. I'm trying not to go too deep into the math behind it, but essentially what it is, as you can see, it's exponential decaying weighting function. So if we have 30 years of data, the most recent data is going to be worth the most in the average. It's because climate trends, they're going up right now, and eventually they'll go back down. That's just how the world works. As you can see there, the older it gets, the less it's worth in the weight. With the 30 years of data, we can then collect, say you pick a day in Montreal, where it's January 15th, right? NASA has records for every hour of that day, for rain, snow, dust concentrations, wind, temperature, and a lot more. Now, if you collect all of that from those 30 days, you can take and apply that curve to it to get an average temperature or other weather data for that hour. Now, weather isn't reliable, as we all know. There's days that are weird, there's weeks that are weird, seasons, some winters are colder than others. That's where we have anomalies, weather trends, right? Now, NASA also has data for this and APIs for this. So what I did is I took the baseline, which was the weighted average, and I combined it with a anomaly-aware, essentially a span of the last 5 years, which is much smaller than 30, to apply the most recent weather trends to the average. Is useful for a few reasons. One, it gets your seasons a little more in line with what they actually are. So if you're looking at like the most recent years, they'll obviously be a little different. Now, putting it all together, I have my formula here, which essentially adds the two together and averages it. For my testing, it seems pretty accurate, within a degree of certainty. It's not going to be perfect when you're predicting the future, especially with weather. So I'll have a little video here to show you the actual web app. So as you can see here, we have a weather dashboard where you can type in and input your own longitude or latitude, or use the leaflet map, which is a great library by this Ukrainian guy, and you can pinpoint anywhere on the map and then pick which types of weather data you want to query. Now once you fetch the weather, it'll reach out to NASA's API and take a look at every, and you pick your day too, it'll take a look at every single hour of every single day for that specific day for the past 30 years. Now once that loads, you can see whatever you picked, which would be, I also have a load data here. So if you have a previous query, I didn't, for the sake of time, it takes about 3 minutes to pull 3 separate pieces of data, just because the years, there's so many, 30 years of data, it takes a long time. I tried running it in parallel, but it didn't really help. So, as you can see here, I have a load data button, which is just for the sake of someone who wants to check different locations or different days. And there are 2 I have saved. So the top one is in Montreal during January 1st, checking for temperature, rainfall, dust, and wind. As you can see here, there are colorful charts for all of them with values that you can hover over for each hour of the day, starting at 12. You can see within 1 decimal spot, but as I'll show you later with the download button, you can actually download a CSV file with more detailed temperatures and more detailed data, down to 10 decimal places or more. Here's the weather report. You get a lot more decimals to work with, which is way more accurate. Obviously still within a degree of certainty. Switch between them effortlessly. And then here I am picking another point, a new date. And you go down to fetch weather at the bottom. And it starts querying the API for like 3 minutes. And then eventually you get back to the same screen with the 4 charts or 5 charts or 1 chart, depending on what you're querying for. Possible use cases. My first thought was, say someone wanted to go on a camping trip or a hiking trip to Brazil. What if they're going in 2 weeks, 3 weeks, 4 weeks? You can't use the weather app for that. So you got to know an idea of what it's going to be like before you buy the tickets, right? Then you got, say, sports organizers. What if they want to find a good day for a match, right? Or, most obvious, space company. They want to launch a spacecraft. They obviously want good weather, light wind, hopefully no rain. Yeah, that's just a few I thought of off the top. Thanks for listening. My name's Leonardo. I have business cards if you want to get in touch. Yeah. Thank you.
Any questions?
Yep.
So the weather data that's sourced, like, depending on the position you're clicking on, is it how is it getting the data from that very point? Is it using like if you click on Halifax, is it getting the weather averages from the airport, like where we're gathering this data, or is it from actual points?
That is a really good question. Actually, so the way NASA does it is they have certain points. They have a lot of points actually, and some of it is satellite data as well.
Yeah.
So you click and you get a latitude and longitude. So the latitude and longitude then round to the nearest spot where they collect data from, which could be Halifax, could be the airport, or if you're off in like Prospect or somewhere else, it could be somewhere they have data over there, or satellite data for like dust concentration, right? Yeah. Yeah.
I like the application. I think it's a really useful tool.
Thank you.
I'm trying to understand like your assumption where you're gathering data from past events and or past time. Like, are you assuming some sort of periodicity?
The word for that would be climatology.
Yeah.
And to a degree, it's less accurate than I would like it to be.
Yeah.
There are models I could have used, but I wanted to keep it to strictly NASA products.
Okay.
Their Facebook creates Profit, which is their weather model, but I didn't want to use Facebook's product and kind of claim it's my work, so I went the very straightforward route, taking the data
Yeah.
and just doing pure math. If I were to extend this project further, I'd make my own machine learning model to recognize global shifts in temperature and anomalies, to be further aware of what it could actually be.
Did you test the validity?
I did, yeah.
How'd you do that?
It's actually pretty accurate. So what I did was I went on my weather app on my phone
Yeah.
and I checked basically what Montreal would be in 2 days, 3 days, 4 days, because that gives me an idea on what the weather app says, right?
Yeah.
And when I ran the same date and the same location, I got within a half degree of accuracy, which I think is pretty decent considering I wrote it in 2 days. Like I said, it could be better with more time, but it's close.
Mhm.
Yeah.
So generally, sorry.
Yeah.
I was just going to make a comment. So generally, I guess your app proves that if, for example, if you look at the last 30 years of what happened today, weather-wise, you can
Yeah.
kind of predict what's going to happen today.
Yeah, it's like I said, weighting. So the last 5 years are going to be worth more than the earliest 10 years, right? So in the average, it'll follow the trends of recent weather. So it is very accurate to a degree. I mean, obviously there's anomalies like storms and whatnot that could spawn out. But, yeah.
I guess, with a machine learning model that learns your data and tests your data.
Exactly, like something like that, where it takes in more than just the NASA data. Maybe it pulls for storms, right? Or indicators of a storm. You know, there's many ways you could push this a little further and get even more accurate data.
Have you done any research on that? It's like, why is there such a strong correlation compared to what happened in the last 30 years?
No, I haven't done too much research into the correlation behind it. I was in a bit of a time crunch. I started actually very late yesterday, so I just jumped right into math, really. Yeah.
Mhm.
Yep.
I noticed, so is this on the web now, where I noticed you were sending this to a local host?
It is a local host at the moment. I
Fair.
could put it up on my website as a subdomain, but I haven't yet.
Totally fair. So it looks like a useful tool that I'm sure people would enjoy, yeah.
It is on GitHub.
It's okay, perfect.
Yeah, the project's on GitHub, yeah. It's using a Python backend with a React front end.
Yeah, I was just gonna ask, what is it built on exactly, but cool, yeah.
Yeah.
Thank you.
Yep.
Did you look into it all, like, so you used like an exponential decaying graph for that? Did you look into it all if it would be, if you think it would be more beneficial to actually look at the trends in between years, like basically percentage wise, and try to model it with that kind of decaying weights rather than just exponential, or?
That is a good idea. But that is sort of what the anomalies do. I have the anomaly detection, which is essentially goes through the last 5 years
Yep.
and takes that trend and combines it with the baseline,
Mhm.
essentially. Is the exponentially decaying function is the baseline. And then on top of that, you put the anomaly aware, which is basically the last 5 years weather trend. So it fits that, retrofits that on top to make it a little more accurate. Yeah, so similar. Yep.
I have a question of my own. Have you done any research on what existing weather apps use, or if there's any existing weather apps for a similar functionality of looking into the future? And if so, by any chance, what distinguishes your app from theirs? Because this is a problem. I mean, the weather app for me doesn't predict what tomorrow is gonna look like sometimes.
Fair enough. Yeah, that's where the anomalies come in. It's very hard to predict weather. Like I mentioned earlier, Facebook has Profit. There are other companies that have their own, whether it be machine learning or algorithm-based weather predictions, and they all operate very differently. I haven't done too much research into how they work. I'd assume most of them are proprietary anyway, but it would be interesting to look at that, yeah.
I highly recommend if you can extend this model to more so the stock and cryptocurrency market. I think
Yeah. That would be a cool project.
if you can.
Worth a shot. Yeah.
Could be a billionaire.
Any final questions?